Good morning, good afternoon, good evening, everybody, wherever you are. Hello, everybody. My name is Dr. Alotaiby from Saudi Arabia, and I'm very honored to co-chair this session with Medtronic session with Dr. Khaled Al-Shaibi. And the title, as you see, is Decrypting TAVI Future Complications. We'll be talking about two main issues, durability and a lifetime management. And as you see here, it's sponsored by Medtronic. The objective of our session is to concentrate on the two major issues, which is the durability and coronary access, making sure that in the future this won't be an issue, considering that TAVI is a very well-established treatment in aortic stenosis, particularly moving to the young population. So the objectives is to unravel the impact of hemodynamics and durability and to reveal the best strategy to enable safer and easier future access for coronaries post-TAVI implantation. And there will be a step-by-step guidance to learn the technique of commissural alignment, which helps access in the future of the coronaries. I am very honored to have two speakers, very well-known speakers, Dr. Gilbert Tang and Dr. Khaled Almerri, and we'll start the first talk by the speaker will be Dr. Gilbert Tang, who is Surgical Director and Structural Heart Program at Mount Sinai of Health System, New York in USA. So please, Dr. Gilbert, the floor is yours.
Thank you very much for the kind invitation, and I'm honored to, on behalf of my group at Mount Sinai, to present this topic of commissure alignment in absolute TAVR, a simple yet predictable method to facilitate coronary access. So here are my disclosures. So lifetime management after TAVR, I think, is getting increasingly important because there is a progression of coronary artery disease, and so there's a need for CAP and PCI, but also TAVR valves don't last forever. So they will need reintervention. So there are two options, either redo TAVI or surgery. So we need to figure out how to manage these patients long term. Well, coronary access after TAVI can be challenging because some of the interventional cardiologists may not be familiar with TAVR and also the features of the transcatheter valves being implanted. There's also variable aortic root anatomy, and unlike surgery, there's other barriers that are facing coronary arteries that are not that can be happen in TAVR, such as a native aortic valve leaflet, the transcatheter valve frame, and also a lack of commissure alignment. So we need to understand the anatomic relationship between the aortic root anatomy and the TAVR device type when we look at coronary access. This is a paper we published a couple of years ago now on looking at a review on coronary access after TAVR with the balloon expandable and self-expanding valve, looking at both anatomic factors, but also device and procedural factors. And from that paper, we actually developed an app that you can download for free on Apple and Android platform that gave you some tips and tricks on how to reaccess the coronaries, both diagnostic and PCI, with both balloon expandable and self-expanding valve. In a recent editorial, we on a paper that was published, we also commented that commissure alignment is important on both coronary access and redo TAVR. So this paper recently published from Jack and Tiffin showed that if you have interference of the commissure of the transcatheter valve, in this case the evolute valve, relative to the coronary artery orifice, it can impede a coronary reaccess. And this other paper, looking at which part of the transcatheter valve interfere with coronary access or make it unfavorable, you can see that in the case of the Medtronic evolute valve, it's around 20% of the time that a commissure will face the coronary artery, making it difficult. And in terms of the sapien-free valve, it's not zero. It's still around 8 to 12, 11% that it can happen. So I think commissure alignment is still a matter in future coronary access and also aortic valve intervention after TAVR. So the rationale of trying to get commissure alignment in TAVR is that as a surgeon, we do it every time in the operating room. And if there's no commissure overlap with the coronary orifice, is going to reduce the barrier to reaccess. And there's now some early evidence presented by the Cedars-Sinai group that commissure alignment may change the rate of halt or leaflet thickening after TAVR and potentially long-term durability. And one final point is that leaflet splitting technique like basilica is not going to be feasible if you have a commissure post facing a coronary to avoid coronary obstruction if you want to consider a redo TAVR. So here's an example of a figure showing both SAPIEN 3 and also Evolut valve that you have a mitral flow valve here that they've done a basilica technique on the bench. You can see that if you have a commissure post, you can see by the red arrow facing the split portion of the leaflet, you can still obstruct the coronary. So it's important to consider commissure alignment in valve as well. So this is a paper we recently published, a multi-center study looking at commissure alignment with 3 different valves. I'll just summarize the research very quickly. It involves over 800 patients, about over half of them were SAPIEN 3, about a third of those a Evolut valve and 100 accurate neo. And what we did is we crimped the SAPIEN 3 valve at 3, 6, 9, and 12 o'clock position, read to the delivery system with the Edwards logo facing up, and we deployed the valve. And with the Evolut, instead of the conventional 12 o'clock flush port position when we insert to the femoral artery, we put it at 3 o'clock instead and let the catheter trap, and then we compare the two. And then for the accurate neo, we look at the commissure orientation. So here's how we do this in terms of co-registration. We have a number of post-TAVR CT to validate this method, but with this method, we do not need to post-TAVR CT to find out where the commissures are. Essentially, what you do an aortogram at the free cuts view, and then you take the picture of the transcatheter valve, whichever it might be, at the same free cuts coplanar view. And in this particular case with the Evolut, you can see what the C-tab is. The C-tab is represent one of the commissures, and you can mathematically superimpose to the pre-TAVR CT and co-register the 2 images to find out where the commissures are. In the case of the SAPIEN 3 valve, you can see that despite crimping at different orientations, we could not get commissure alignment consistently. And this has recently also been reproduced from the Cedars-Sinai group at the TCT presentation. With the Evolut valve, you have the C-tab, which matches the and you can see that with the head marker as well, where it's located at the time of deployment is a outer curve at the black band. You can have a center front facing you and the inner curve. So you can see that the C-tab has a mathematical relationship to the head marker. It's approximately 90 degrees from each other. You can see that right here when the valve is being loaded. This is a constant relationship, and your Medtronic specialist does this every single time. And why this is important is that at the time of the Evolut deployment, you can see from the paper that around 80% of the time, the head marker at the time of deployment at the annulus will be either the outer curve or center front facing you, and about 20% of the time is the inner curve or center back at the time of deployment. Now, what this translates to is that when the C-tab gets released, you see that majority of the cases, the C-tab will be at the inner curve of the aorta. Some of them will be in the center front facing you, and then some of them will be in the outer curve in the reverse C, or rarely at the center back. The reason why this is relevant is that if you go back to looking at the commissures where they are, if you have the head marker of the delivery catheter at the time of deployment at the inner curve or center back represented by the red bars, the incidence of severe overlap with the left main, the right coronary, both, or one or both, is much higher than if your head marker at the time of deployment is at the outer curve or center front represented by the green bars. So it's statistically significant and it's pretty dramatic difference. So what we like to do then is to improve the way we can deploy the Evolut valve by putting the head marker at the outer curve or center front as much as possible. And to do that, we've discovered that by putting simply the flush port of the delivery catheter at 3 o'clock rather than 12 o'clock and insert it into the femoral artery, it improves the outcomes of the head marker positioning. And so the goal to do this is to try to land the C-tab at the inner curve of the aorta every time, whenever possible, so that we can optimize or improve our commissure alignment and also facilitate coronary access after TAVR potentially. Now, where is this flush port? This flush port is located here. You can see at the orange circle here at the gray handle. So when you insert this rather than 12 o'clock facing the ceiling, it will be away from you at 3 o'clock. And to be able to do this, you can just insert it into the femoral artery. So how do we do this is you can see the head marker is tracking at the outer curve of the descending aorta as it tracks across the arch, and it becomes the outer curve at the annulus. So you can see that very nicely on the left video. And when you position the delivery catheter across the annulus, you'll see that at the classic or LAO view, your head marker of the outer curve. And if you're doing cusp overlap view or the RAO caudal view, you'll be center front facing you directly. And so by doing so, you can see that when you release the valve, very often the C-tab will be the inner curve of the ascending aorta. And so when you co-register with the pre-TAVR CT, you see that you can good commissure alignment. So this is an animation showing you how this is done. You can see that by having the flush port at 3 o'clock, the head marker will be tracking along the outer curve of the ascending aorta towards the aortic root. And once it crosses the annulus, when you do the cusp overlap view, as shown in this animation, the head marker will be facing you directly most of the time. And so you just deploy the evolute valve in a standard manner using the cusp overlap technique as shown here by doing control pacing initially and let the valve flower slowly to engage the annulus. And you can see the blue bar there represent the membranous septum and the conduction system. So the idea is to start a little bit above the annulus and let the valve go into the annulus, into the LVOT, to avoid interacting with the membranous septum and the conduction system. So you can see here now under control pacing, the valve is getting flowered. And you can see that it's going to engage the annulus very shortly. You want to inject to make sure you are staying just below the annulus at the inflow of the valve. And then you go quickly to the 80% with the rumble strip ends to assess the depth and also the any anatomical risks. And once you're happy with that, you can proceed to deploy and release the valve very slowly. And the point of this animation here right now is so that you can see the head marker, the outer curve in the LAO view. And as you slowly deploy and release the valve under control pacing, you'll see that the native commissure is aligned pretty well with the C-tab or one of the evolute commissures. So once you're ready to release the valve, you can see under control pacing, you'll see very shortly that the C-tab is well aligned with the native commissure. And that allows to give you more open cells to reaccess the coronary. And you can see that right there. So what we've done now is over 300 consecutive cases using this technique since last year. And what we found is that we are able to get the head marker to, from the outer curve to center front from 70% with the 12 o'clock conventional technique to now over 94% using the 3 o'clock flush port modified technique. And as a result of that, our incidence of severe overlap with the coronaries are dramatically reduced. You can see that from 38 to 21%, from 31 to 13%, from 20 to 13%, and from 14 to 5.6% with both coronaries. So it's a significant improvement compared to if you were to insert the delivery catheter at the 12 o'clock conventional way. So here's a case to show you. This is a conventional implant deployment view, LAO caudal. You can see that the head marker is at the outer curve of the ascending aorta. And so when you release the valve, the valve is released. You can see the coplanar view that is the C-tab is in the inner curve. And this patient had a post-CT study. This patient was a part of the evolute low-risk study. And you can see that the commissures are well aligned on the post-CT. And in fact, this patient required coronary angiography after the TAVR procedure. And you can see it was very easily done to selectively engage both coronaries. I'll show you another case. This is a cusp overlap view with a 23 evolute valve. You can see that as the delivery catheter is at the annulus, is facing you in the center front. That's where the head marker will be. And then when you release the valve, you can see the LAO view, the head marker is now in the outer curve. And when you look at the valve again, at the coplanar view, you can see that the C-tab is the inner curve, and when you co-register to the CT, it's got a pretty good commissure alignment. On the cusp overlap view, the C-tab will typically facing the right side, very much almost you can't see it, so you have to rotate it in the coplanar to visualize the orientation. So there are some limitations with this technique. This is a transfemoral only approach. This is not tested in the alternative access. The iliofemoral tortuosity or calcified vascular anatomy may limit the ability to track the head marker to the outer curve in the descending aorta and the LAO view, especially the left femoral access. So it doesn't work all the time. Remember, this delivery catheter system is not designed for commissure alignment. This is just a modified technique to improve it. So in summary, I would say that the commissure alignment would make the coronary access after evolute TAVR easier. Inserting the delivery catheter with a flush port at 3 o'clock, the modified technique improves our head marker to position the outer curve for center front now over 94% of the time. And the head marker, the outer curve, or center front, depending on which view you implant during the initial deployment, can optimize commissure alignment. I'd like to thank you very much for your attention, and please feel free to reach out to me for any questions or comments about this presentation.
Thank you, Dr. Gilbert, for this nice presentation. Let me start with a question. Is this useful in valve-in-valve procedure?
Great question. So we have not done a lot in valve-in-valve because the valve-in-valve is different from native TAVR in terms of you have a rigid frame, usually a standard valve in the way. So when you cross the delivery catheter, it might be challenging to get it to the outer curve. But we tried doing the 3 o'clock flush port technique, and majority of the time it does work very well. And I think it's important, especially in cases where there's a high risk of coronary obstruction.
Now, if you need, is there any preferable access for those who had TAVI and you need to revisit their coronaries? Do you prefer any certain catheters or approach, radial or femoral, or those with they have evolute in and you want to see the coronary?
Yeah, I think with the evolute being the tall frame, I mean, I'm not an interventional cardiologist, so I can't speak too much about the approach, but my interventional colleagues, when they try to reaccess the coronaries after TAVR, typically will be femoral, because you have more control and more delivery catheter at your disposal in terms of the level of support that you need to cross, especially in a PCI situation.
Dr. Shaibi, any question? Please go ahead.
Yeah, Dr. Tang, you very nicely demonstrated how you can achieve relatively consistently commissural alignment with the evolute valve. But is this possible? Is it as important with other valves, especially the balloon expandable valves that have a shorter stent frame?
Yeah, that's a great question. The balloon expandable valve, as you saw in the paper that I showed, that's around 10% of the time that a commissural tap faces the coronaries. Now, it might not be critical to reaccess the coronary because you might be able to go around the tap across the frame. But what might be important is the issue of redo TAVR. So if you have a balloon expandable valve that the frame reaches above the sinotubular junction, if you have a very short distance between the frame and the coronary and the STJ, it's going to seal off the root very much like a valve-in-valve situation. So you can still obstruct the coronaries. Now, if you have a commissure facing the coronary, you're not going to be able to do any kind of basilica or splitting technique to avoid that situation. I mean, we're still exploring this right now, but I think that's why commissure alignment is important for all the valves. They also, the cedar-cyanide group showing with the balloon expandable valve, there's for some reason a bit more halt they found when the commissures are not aligned. Now, we don't know what the long-term impact of this is, but certainly it's still an ongoing question to explore.
Dr. Almerri, any question?
One other question.
Yeah. My question here is, we're talking about now to implant this, now the TAVRs as high as we can. And since we're talking about coronary access, we're talking about patients who are low risk, younger patients, they should have a good accessibility. So if we start implanting high, so the scale, let's say for evolute valve now, it's 30 millimeters, means your access can be a problem. Should we readdress the height of the implantation? The other question is, if you go in with the valve and you find the hat of the valve is not on the outer curvature, what's the best way to correct it? Pull it back and turn it, or you can turn it inside the valve?
Yeah, those are two great questions. Let me answer the second question first. We don't recommend twisting the catheter once you're in the patient because there can be risk of damaging the spine. Again, I want to emphasize that this delivery system is not meant for commissure alignment. This is just a technique to improve it, and I'm sure newer technologies down the road will be able to do a better job to get consistent commissure alignment almost 100% of the time. Also, remember the head marker, even though it's outer curve or center front, when the valve is released, it might still not have the C-tap rotated properly because just the way the valve gets released. So my recommendation is that whatever happens when you insert the delivery system into the patient, just let the delivery catheter track to the annulus and deploy the valve in a standard fashion. I would not attempt to torque or twist the catheter in any way right now, based on some of the early findings, until we have some more definitive answers from the engineering team later on.
So you put the flush line 3 o'clock while the valve is outside the patient.
Yes, yeah, exactly. When you insert to the patient with the flush port 3 o'clock away from you, you just let the delivery system track whichever way it tracks, because remember, this delivery system has two spines in the body. So you're not trying to force the delivery system stay at 3 o'clock the entire time. I want to make sure everyone here knows that. Once you put it in at 3 o'clock, you just let it go just to deploy the valve, advance the valve the way it's supposed to be. There's no additional maneuvers or tricks to it. It's just a simple modification of how, which orientation you insert the delivery catheter, that's all. In terms of your first question, in terms of implanting high, we're not advocating implanting above the annulus. We're not a supraannular implant. We're still aiming for around 2 to 3 millimeters on a non-cusp. Your point is well taken in terms of the ceiling skirt is around 13 millimeters, but the SAPIEN 3 Ultra valve is also quite high in terms of the ceiling skirt depending on the valve size. Typically, the ceiling skirt is not going to be exceeding above the native leaflet height. As you know, the coronary height may be lower than the ceiling skirt height, but it's very rare that the ceiling skirt will be exposed above the native leaflet. However, that's where commissure alignment is important. You can imagine with a tall supraannular leaflet with the tall commissure, if you have that facing on the coronary, now you have less room on either side to try to reaccess because you have fewer cells. So, but if you have a trough where the base of the ceiling skirt, which is around 13 millimeters here, as you mentioned, now you have a lot more cells to choose from to access the coronaries when you have a good commissure alignment. And I think that's what my takeaway message for everyone is. If you're able to do that, it just gives you more possibilities to cross the evolute frame to engage the coronary, no matter how difficult the coronary anatomy might be.
I think we need to move on. We may be running a little short on time. It gives me great pleasure to introduce our next speaker, Dr. Khaled Almerri, a good friend and a consultant interventional cardiologist at the Chest Disease Hospital and at Al Salam International Hospital in Kuwait, where he also serves as the director of the catheterization laboratory. His talk is entitled The Impact of Haemodynamics and Prosthesis Patient Mismatch on Durability. Dr. Almerri.
Thank you, Khaled. Good afternoon, everybody. Thank you very much for having me in this great session. So what I'm going to talk about is hemodynamics and valve durability. If we look to the search for the ideal prosthetic valve substitute, I think the ideal valve is the valve that will behave like native valves, which has a good effective orifice area with no gradient, durable, with no anticoagulation. And obviously, we haven't reached that point yet. So if we look to the trend of the type of valve, prosthetic valve implanted in aortic position, we find the rate of the bioprosthetic valves has increased over the last couple of decades on both sides of the Atlantic. And if we see the slide here, we see the numbers has gone until 2012. And after that, we had more evidence with the usage of TAVI valves in lower risk patients and younger patients, which means tissue valves will be utilized even more. And two important things in considering prosthetic valves, basically you want to have a good orifice area and no gradient. And if we look to if the indexed orifice area becomes smaller, we'll find gradient. So if the patient's body size increases in a certain valve size, we expect the effective orifice area will be less, the gradient will be more, and as we increase the cardiac output, that problem can be more. So then we come to the concept of patient prosthesis mismatch. And basically, if we look to the type of the tissue prosthesis over years, if we look to the right side graph, we see the clear bar has been increasing over years, which is patient with tissue valve that does not have PPM, which means our friends from the surgical side has identified that problem, worked hard to improve it, but yet half of the patient will still have some PPMs. And that problem is more in patients with small annuli. Is that a problem? The answer is yes. PPM increases the risk of death, heart failures, and redo surgeries. And the problem with the PPM doesn't start early or late. Basically start from the time of the operation until even 10 years. So still the risk of increased mortality is there. Not only mortality and heart failure, but also symptoms. New York Heart classification or heart failure symptoms, patients with PPM will continue to have their symptoms, and they will continue to have more diastolic dysfunction and may get worse by time. Is that problem found in trans-heart catheters or TAVRs? The answer is yes. 1/3 of the patient who gets TAVRs, they will have some sort of PPM, moderate or severe. Is it more common in redos or TAVRs? Obviously, from the data we have, PPM, it is present with TAVRs, but it is less common compared to redo surgery. So again, this problem is common in small annuli and TAVR patients. So the predictors for PPMs are obese patients, small annuli, small effective orifice area. Is the problems that we have seen in PPMs and surgical valve present in TAVRs? Yes. So patients with PPMs after TAVRs, they have higher risk of heart failure. Not only that, is also higher risk of mortality. And again, if we look to the size of the valve that we use in TAVR, PPM is present in all types of valves, large, intermediate, and more pronounced in small annuli. And if we look to the data from the self-expandable valves, we find patients who had TAVR with self-expandable valve, whether they are high-risk patient, intermediate or low risk has significantly low ppms. And if we look to the performance of core valve over time, we find the effective orifice area and the gradient is maintained over 8 years. And if you look to the famous Notion trial, low-risk patient who had core valves, over 8 years, they maintained their good effective orifice area over time and gradient across the valve. And recently, we have seen evolute in low-risk patients, and in those patients, we find significantly lower rate of lower gradient across the valve and better effective orifice area compared to the surgical valve that we haven't seen in the balloon expandable trial. And at 2 years, that good result is maintained. And if we risk stratify the patient to large, intermediate, low risk, and low risk patient trial, we find the ppm is less in all the type of valves that been used and more pronounced in low or small annuli. Interesting finding, in that study, we find that the ppm increases as the annulus becomes small, but that increase was not seen in the TAVR with evolute in the low-risk group. Comparing to balloon expandable, and comparing the supraannular self-expandable valves, they have a lower gradient across the valve compared to the intraannular and better effective orifice area. And that is reflected on the ppm presence. Valve-in-valve is a new emerging issue that with TAVRs and tissue valves, and it account now to 5% of the TAVRs at this time. And if we look to the self-expandable supraannular valves, they did better than intraannular in this group of patients. So what's the reflection of the ppm on structural valve deterioration? Well, patient with ppm, they have higher risk of structural valve deterioration. If we look to the risk of valve deterioration is basically the data from surgical trials. And basically those patients are patients who had surgery. And the patient who had failed valve did not go for surgery, were not included. And that's estimate the number of patients who really have structural valve deterioration. But if you look to this big meta-analysis, at 10 years, 6% of patients had redo. And after that, by 5 years, that number is doubled. By 20 years, half of the patient needed surgery. But if you look to the VIVID registry, some valves did better, some valves did worse, but most of the valves failed at 8 to 9 years. And if we look to the data from the surgical trials, we find the definition is variable, and there is no standardized definition of structural valve disease or deterioration. Then we have 2017, a good definition from the ESC and the other societies that define what is structural valve deterioration. So if we look to the UK TAVI trial, we find the risk of the SVD is very small in this group of patients. And that was seen in the French and Canadian papers. But in general, the SVD in TAVI patients, if we look to multiple trials, is from 0 to 6%, which is really low. And the predictors are basically small annular annuli and the valve-in-valve procedures. If we look to the performance of core valve over 5 years, we find in high-risk patient, core valve did really great compared to the surgical valves. So if we look to the NOTION trial in low-risk patients, we find the rate of structural valve deterioration with core valve is low. And this is an important issue now, since we are going to expand our indication for TAVR to younger patient, low-risk patients. We are going to get patients who are in their 60s, and their life expectancy will be longer than the life expectancy of the valve. So we'll expect patient to have a valve-in-valve, and in their lifetime will have another valve-in-valve most probably. So conclusion, patient with PPM PPM is a serious issue. It is common and carries bad prognosis. We should anticipate that in patient and try to avoid that problem with proper planning of the procedure. Valve sizing is important. Thank you very much.
Thank you very much, Dr. Berri. I'd like to start the discussion off maybe by asking, is there a certain annular size below which your default will automatically become a supraannular self-expanding valve?
So we know patients with annulus or annuli less than 23, they carry higher risk of PPM. So once you find a patient with that, you have to do all the needed you have to do all what is needed to reduce that risk PPM. Otherwise, this patient will not benefit from this procedure, most probably.
Do you use a straight cut of 23 millimeters? Because in our part of the world, as you realize, we do tend to have smaller annuli, but our patients are generally smaller in size as well. Do you look at the effective orifice area or the annular size as reference to the body surface area, the size of the patient, to make that determination as well?
Yeah, I think we have to look to the size of the patient. If we look, or in the VARC-3 definition, they included the body mass index of the patient. So the bigger patient, they will have a lower number of index effective orifice area to call that severe patient prosthesis mismatch. Yes, definitely the size of the patient should be taken in consideration.
Dr. Tang, Dr. Alotaiby, do you have any questions you'd like to ask?
Yeah, thank you, Khaled. Now, do you recommend doing hemodynamic assessment post-TAVI insertion in all patients? Because I know some people, they don't do it routine. And personally, I do it when I feel that I need to calculate the IA index to see is there paravalvular leak or aortic regurg. But can we set up like the baseline hemodynamic? Do you recommend that to be able to define the PPM in the future in that particular patient?
If you're talking about TAVI insertion immediately, I think we go by the gradient. So we don't need to do cardiac output. We just check the gradient across the valve and see if there is a gradient and you need to dilate that valve, I would go with that. But sometimes you see the valve is too big for that annulus and still there is gradient. And if you post dilatation, you will cause problems. So I go with the gradient only. And if we can stretch the valve more, we do it if there is a gradient.
So obviously there is another point which you mentioned, which is important, to prevent structural valve deterioration. So you don't want a gradient, but you don't want structural valve deterioration. How do you decide, and if you decide to post-dilate? I think it's important to, can we exceed the valve size of the TAVR, or that's the upper limit we shouldn't exceed at all?
we always talk about ballooning a TAVR we may injure the leaflets, but I think, yes, we can post-dilate the valves. And I think the answer is yes, we can, under expanded valves, we can balloon those valves, yes.
I'd like to ask Dr. Tang a question, since we don't often have a surgeon sitting at our tables, and especially as this is as TAVR or is moving to lower risk patients. In our part of the world, especially women, tend to be quite small and sometimes have really small annuli. You're talking annuluses in the range of 18 and 19 millimeters. Do you think that in that group of patients, surgery and aortic root enlargement has a role to play in building a lifetime strategy for such a patient?
And great question. So, thankfully, our center at Mount Sinai has a raw surgeon expert, Dr. Ismail Al-Hamzi. So we actually have a good heart team discussion in younger patients, particularly patients younger than 70 or even 65, where, as you said, any prosthetic valve, whether it's surgical or transcatheter, is going to have limited durability, and it's likely going to require more than one re-intervention. So in those patients, if the anatomy is suitable and the wrist is acceptable, we would offer what we call the Ross procedure, which is probably the ultimate root enlargement you can think of, and it's the patient's own valve. So the durability out there, in terms of number of randomized trial or longitudinal data, has shown excellent durability with the Ross procedure, almost like 15, 20 years. So by that time, if the valve does fail, you basically treat it like a native TAVR. It's a very straightforward way to do it. Having said that, in terms of root enlargement, I would say I think there's a recent paper and experience published from the Brigham Women's Hospital, and also some experience from the Columbia University on patients with aortic root replacement for valve-in-valve procedure, or maybe having the root replacement as the first operation. Now, it does increase the risk of the operation, because you have to reimplant the coronaries. But in young patients, I think that's probably the ideal way to do it if you cannot do a Ross procedure, because a root replacement, you can put as large a valve as you want. There's no restrictions at all. And I know 25 or above should not have any kind of prosthesis patient mismatch. The other thing about small women, I want to caution the audience, is the whole issue of hyperdynamic left ventricle and perhaps some element of hypertrophic cardiomyopathy. So even though we release aortic stenosis, they often have a residual LVOT gradient. And so symptomatically, they might not have a complete resolution of their diastolic dysfunction. So I think those patients need particular attention to, not just fixing the aortic stenosis, but look at other physiology as well.
If you have somebody who's young and you will anticipate that he will have 2 procedures, so would you think of AVR, then TAVI, AVR, TAVI, and TAVI?
Yeah, no, that's a great question. So it was just recently discussed also at other meetings. So I think you look at the CAT scan, initial CAT scan, to see what the options are. If the aortic root is small, you want to put in the first valve that is the best hemodynamics to the patient, and so that, hopefully with the longest durability, and then worry about whatever happens later on. But if the aortic root is large enough and you can fit a transcatheter valve that can enable you to do a redo TAVR later without causing mismatch or causing functional AS, then I think it's reasonable to have that discussion. And finally, I think there are, surgical valve durability are very good now. So if the patient is 70 plus years old, and obviously TAVR will be the first choice, but we always talk to them about the durability of TAVR is unknown, and they may need surgery later on to take out the valve. And some patients may opt to have a surgical valve now because the root is generous enough on CT scan, and they can have a straightforward valve-in-valve TAVR later on when they're in the 80s, where you want to avoid open heart surgery. So I think there's still a lot to learn. We don't know, but we always have a heart team discussion with the patient so they know all the options, and then the patient can choose as long as they understand all the pros and cons.
Well, I'd like to thank our speakers, Dr. Tang and Dr. Merri, for wonderful talks. I think I learned a lot. I hope you did as well. It's now time to move on to our take-home message. In the past, when TAVI was primarily performed in older, higher-risk patients, success was defined as a successful implantation with no major adverse cardiac, neurological, or peripheral complications. As we move TAVI into lower risk and especially younger populations, we need to redefine the objectives of treatment and the definitions of success. These younger patients have a longer expected life expectancy, and hence durability of the valve carries greater weight. And with a longer life expectancy comes the increased potential of developing coronary artery disease requiring coronary angiography and percutaneous intervention. Hence, future coronary access becomes increasingly important. As these patients live longer, the importance of valve durability, the need for a second or third intervention need to be considered when planning the first procedure. A lifetime plan needs to be proposed at the time of the first procedure. It may include considerations for both surgery as well as TAVR, as well as the choice of TAVI valve that may influence future valve-in-valve procedures. We heard from Dr. Almerri that moderate and severe patient prosthesis mismatch can impact the durability of both surgical and transcatheter heart valves. Furthermore, it can also impact survival and repeat hospitalization for heart failure. The lower incidence of moderate and severe patient prosthesis mismatch, especially in patients with smaller aortic annuli, gives supraannular transcatheter heart valves a distinct advantage of both surgical and balloon expandable valves in this patient subset. Dr. Tang beautifully illustrated how both anatomical as well as valve-specific consideration may impact future coronary access, or indeed the probability of coronary occlusion during future valve-in-valve procedures, both important considerations in a younger patient population. He also elegantly demonstrated how commissural alignment at the time of initial valve implantation can be achieved consistently with the Medtronic Evolute platform, hence facilitating future coronary access and future valve-in-valve TAVI reintervention. So that brings us to the end of the session. I would like to thank my co-chair, Dr. Mohammed Alotaiby, as well as our two outstanding speakers, Dr. Gilbert Tang from New York and Dr. Khaled Almerri from the Chest Hospital in Kuwait. Thank you very much, and thank you for attending this session.
That was such a great session from the sponsored session from Medtronic. I think, education has always been about simplifying things. I really, really like, a simple added technique during catheterization that would make a huge difference. For example, as illustrated by Dr. Tang, if you change the position of the flush port in the Evolute delivery system from 12 o'clock to 3 o'clock, that makes a huge difference in terms of commissural alignment and future access for the coronary anatomy. So that one part I really liked a lot about the presentation. Obviously, the other aspect would be, in the initial days of TAVI, we always thought about the safety during the procedure. And as time goes by, we think more about the future of the patient. So the valve durability, the future access, the durability of the structural valve, the patient prosthesis mismatch. So all these things are important aspects to think about and plan procedures accordingly. So it was a great session. And I think maybe for me, the one take-home message is, simple 3 o'clock flush port will orient your commissures quite rightly for future access. So that's a simple action that will have great impact.